How far did you get? We got the video going.
Is that live right now?
It's not live, it's taping. I have trouble with the live.
Are we gonna go live someday?
We have gone live a couple times.
So like, how do you like find the videos?
We didn't know it.
Classes? Is it all like just taken from like one class? Or?
No, I'll show you after class. I'll show you.
Where is it on
All right.
Schoology? Like,
Here we go.
Doesn't
No,
say
the
where.
videos are not on Schoology. They're on my website. They're on my website. Somebody said though, if you just go to YouTube and put in Lisa Ford, all the videos pop up. I don't know if that's true because I don't know how to do that, but I can show you how to access them. They're all linked on my website. All right, here we go. Did you first of all switch your variables? So x equals y plus 5 over 4y minus 1. Right? Then what happens? Emma Faulkner, what'd you do next?
I multiplied everything by the denominator.
So you had x, 4y minus 1 equals y plus 5. Then what did you do, Emma? You distributed. So you had 4xy minus x. Remember, distributed means you multiplied all the way through. Chase, you know what happens now? You did the distributed there.
You switch the x and the y.
These two have to switch places because the rule says the y's have to be on the same side. So we'll bring the y over and add the x over. Right? Rylan, what happens next? We're almost done.
Take the y out.
And take the y out. Now this one's a little tricky. Be careful. When you take out a y, you have 4x minus 1. And then we'll divide both sides. So, before I started blabbing, did anybody get x plus 5 over 4x minus 1 as the answer? Okay, so we are ready tomorrow. We know exactly what we're going to do. I'm going to give you a half sheet of paper, and you're going to do one of these problems. Right? Okay. Now, no. Moving on. Number 2. I'll do more of these in flex for anybody that wants to come to flex today. Is the thing a function? So look at problem A, that little parabola. Is it a function? You should be able to answer that question. Yes. Why? It passes the vertical line test, right? The vertical line test, it passes it. We are on the back of page 11, problem number 2, number 1, right where we left off yesterday. Now, the next question is new. The next question says, is the inverse a function? And the answer is no. It fails the horizontal line test. Now let's talk about that for a minute. You've never done the horizontal line test before. Let's talk about it. If I draw, this is my picture. If I draw a horizontal line, do you see how it hits the curve twice? Now let's talk about those 2 points. This might be the point, I'm making this totally up, but that might be the point -3, 2. And this would be the point 3, 2. Now there's nothing wrong with those 2 points, but what happens if I turn them around? The question said, is the inverse a function? Well, if I turn these points around, because that's what I do when I make an inverse, remember? We turn the ordered pairs around. Then I would have the point 2, -3 and the point 2, 3. Is there anything wrong with those 2 points? Yes, their x's repeat. if you wonder about the inverse, you have to do the horizontal line test. Because in when we switch the ordered pairs, the y's are what become the x's. So when someone says to you, is the inverse a function, do the horizontal line test. This has 2 points, so the answer is no because it fails the horizontal line test. Is it 1-to-1? No, it doesn't pass both tests. In order to be 1-to-1, you have to pass vertical and horizontal.
How come we didn't do the horizontal one on the one right before, the f of x equals 4x plus 2 over 9?
I think I'm in the wrong. Are you on the back of page 11?
Yeah.
Down at the bottom? There's no equation there. We're just going totally from the picture. So
Oh. I was looking at the ones up here. I was confused.
No, we're down here at the bottom.
All right, yeah, got it.
Looking just at the picture.
Okay.
We're not looking at equations right now. We're doing the vertical line test and the horizontal line test on the pictures. Okay. To answer question 1, is it a function? Use the vertical line test. To answer question 2, is its inverse a function? Use the horizontal line test. To be 1-to-1, you pass both of them. Okay? So let's look at the second picture. Is it a function? It is that sideways V. Is it a function?
No.
No. It is not a function. So the answer to number 1 is no. And the reason is it fails the vertical line test. And you can abbreviate. Now, is its inverse a function?
Yes.
Yes. It passes the horizontal line test. Is it 1-to-1?
No.
No, because it has to pass both, right? All right, let's do the last one. Is the third picture, C, a function?
Yes.
Yes, it passes the vertical line test. Is the inverse a function?
Yes.
Yes, passes the horizontal line test.
Yes.
Is it 1-to-1?
Yes.
Yes, passes both. Think about your BFFs. Can you think of another BFF? This is like the identity. C is a version of the identity. Can you think of another BFF that passes both tests? So in other words, it would be 1-to-1. Audie?
The cube.
Cube, absolutely. Great choice. The cube is 1-to-1. Doesn't it pass vertical and horizontal?
Square root.
Square root? Does it pass vertical and horizontal? There's some more. Let's get one more.
Exponential.
Exponential. The exponential passes vertical and horizontal. And there are others. There are several others. Now, think of a BFF that isn't 1-to-1. Absolute value.
Square.
Squaring. Yep, good choices. So some of our BFFs are 1-to-1 and some of them are not. To be 1-to-1, you can check it real quick. You just check the vertical line, check the horizontal line. It's got to pass both. Got it? Okay. Now we're going to sketch some inverses. This is easier than you can possibly imagine. Here is what I want you to do. While I am drawing the picture, would you go through and label each point? So what I mean is this point right here is 0, 1. Would you go through and label every point? You'll see why I'm doing this in a minute. But just label every single one of the points in that picture. Okay, you got them labeled? Now I have to sketch the inverse. That's my original. I have to sketch the inverse.
So you just
Anybody have it? What?
flip it,
Flip what?
like over the y-axis.
Actually, it doesn't flip over the y-axis. It's a little trickier than that. It actually flips across the identity. It flips across the y equals x line. But it can be easier than that. It can be done that way completely, but it's easier than that. Schlebecker?
Yeah.
You had your hand up.
I did.
Oh yeah, it was up like this, and I don't know if you were stretching or scratching or what you were doing, but your hand was up. You have an idea? Sam?
Switch the X and Y.
Exactly. All you have to do, kids, is take each ordered pair, and I'll start over here to be organized, and you just flip-flop it. Remember, with inverses, the y and x switch. So instead of plotting -4, 0, I'm going to plot 0, -4. And then -1, -3, and so on. I'm just flipping each ordered pair.
So we don't change the signs at all.
We don't change any signs. You just flip them. And I would suggest that after you get a few plotted, that you go ahead and connect them, because you need to connect them. And sometimes if you get too many points in there, it's hard to connect them in the right order. So we want to connect them as we go. Quit yawning. This is fun. Don't tell me you're tired. There it is.
Wait, why is? Oh, never mind. What? Yeah, never mind.
Okay.
Yeah, I'm fine.
Now notice that in the original picture, this trapezoid thing was on the x-axis, attached to the x-axis. Now, where is the trapezoid thing attached? To the y-axis? Does that make sense? Yes, because you switched the variables. So what was associated with x is now associated with y. Don't change the pluses and minuses. Don't change the signs. Just flip-flop the ordered pairs. Okay? Can you do the second one on your own? Remember how I started? I started by plotting the original, or by labeling the original points. So now when I flip them, Guadalupe, does that look like yours? Good. Rest of you okay with that? How easy is it to graph an inverse? So easy. You just take whatever the original ordered pairs were and you flip them. All right. Part 4, we are switching gears. We are looking at a a more complicated set of equations. So let's just take a minute and catch our breath. Does anybody have any idea? Read the directions. Find xy if t equals 1. Any idea? Plug 1 in. So even though it looks complicated, this is like super simple. We plug 1 in. So what will be my x value if I plug in 1? 3. What will be my y value? There we go. There is the answer to the question. It is that simple. So let's look at the second one. Do not make this hard. We are letting t be 7. So what are we going to get for our x value? 2. What are we going to get for our y value? 49. Done. Simple.
What?
Alright, so now I'm on to part 5. And it says find a direct algebraic relationship between x and y. What that means is write one equation with x and y as your variables. So in other words, instead of having 2 equations that include t's, you're going to have one equation that has just x's and y's. Okay? Now you might not have ever done that before, but you know how. Anybody have an idea on how I might get rid of the t's? That's basically what I want to do. Isabel?
Would you set t equal to something for
She says, what about using good old-fashioned substitution? If we, for example, right here in this second equation, she said, what if we divided by -2? So t would be y over -2. Does that make sense to you in that bottom equation? And then she said, take this and plug it in right here. So that equation would now be x equals 3 times y over -2 plus 1. You see what she did? It's ingenious. She said, let's get t by itself.
But then you can't solve that.
No, you can't solve it, but the directions Ferris say write one equation.
Okay.
So now how many equations do I have?
1.
1. And what are the variables? X and y. Now I probably want to clean that up a little bit. It's not a very pretty equation. So this would be 3y over -2 plus 1. Remember when you multiply top times top, bottom times bottom. And then if you wanted to get rid of the fraction, you could, multiply everything by -2. So -2x equals 3y minus 2.
But then we have to divide the -2 again to keep x by itself.
Okay, we don't need x by itself. There's no rule that says x is by itself. And in fact, usually we don't get x by itself, we get y by itself. So if you're going to do that, you would add the 2 and divide by 3. I am really okay with this equation.
Are you fine with just the first equation?
This one
Yeah.
right here, probably not because it had a fraction in it.
Okay.
But I'm okay with this and any version of that. So if you want to add or subtract 3y, I'm okay with that. If you want to get y by itself, I'm okay with that. So all of these are fine.
So
I
just like,
really don't care.
as long as it doesn't have a fraction,
Yeah.
you're fine.
Yeah.
Okay.
So let's make sure we're clear on what we just did, because all this is kind of optional. This and this and this, these are kind of optional things. We took the original two equations and we got t by itself. Now, she didn't suggest which equation. I just picked this one because it looked easy to get t by itself. Could you have gotten t by itself up here?
Yeah.
And then plugged it into this equation? Yeah, and it would have looked a little different, but it would have been perfectly okay. The goal is get t by itself in one equation and plug it into the other equation. Alrighty, we're gonna do one more and then you can escape for the day. Let's see if we can figure out how to do it for this second problem. Okay, so Abby, my job is to get t by itself so that I can substitute it in. So which equation do you think it would be easier to get t by itself in? The top. Be real easy up there. We'll just subtract 4. So t is x minus 4. Right? Now what am I going to do with that x minus 4 right there? I'm going to plug it in right here. So y equals 7 times x minus 4 minus 3. Or 7x minus 28 minus 3. And oh, this one's going to work out beautifully. 7x minus 31. Y equals 7x minus 31. Mason, are you awake?
Yeah.
Okay. You're thinking. Good. All right, well, we will pick up here tomorrow after we take our quiz, which is one problem, like we practiced at the beginning.
Is there a bonus?
There can be a birthday bonus tomorrow, yes. If we have a birthday.
Well, yeah, my birthday is
Really, your birthday is tomorrow? You already had your birthday. Your birthday's tomorrow?
Yeah.
For real?
Yeah.
You're lying.
No, I'm not. No, my birthday is this Saturday. This is 4th.
Is it?